Assalamu alaikum. Recently, we have started a series of lectures about DICOM image processing. So today is our fourth one lecture about augmentation. So image augmentation involves applying various transformation to the original images to increase the dataset diversity. We can rotate the image, we can flip the image at any size, at any angle. So these are augmentation. So its purpose is only for to help the limited medical image data, and we can say that model handles variation due to patients' positions and equipments, and we can further say that it is also increase the number of data sets. How can we increase the image data set? Rotation of different views, flip for imaging, and noise addition for equipment variations, brightness, contrast adjustment for the diverse lighting. So ensures accurate and robust medical image analysis without distorting clinical information. In the previous lecture, we have learned how to load and how to do zero padding to the DICOM images. That video you can find on my channel, list DICOM image processing. So today we are going for DICOM image augmentation. Come to the code block. First line is import numpy as np. It's only for numerical operations. This libraries include only for numerical operations, and plt for data visualization. As we know that PyDICOM is library for working with the DICOM images, and import cv2 library for computer visions and image processing tasks. So we process this and go further. Here we can I can also tell you that instead of cv2 dot flip, you can use np dot flip from numpy to achieve a horizontal flip. So it is important to note that OpenCV provides a more comprehensive set of functions for image processing and computer vision tasks. So that's why I use this. So next line is code about load DICOM images. Here you can just use the address of your image. It's go for enable interactive plotting mode for Jupyter Notebook or Jupyter Lab. As you are seeing this line, matplotlib inline in a magic command that allows matplotlib figures to be displayed directly within the notebook. So this ensures that the image will be displayed in a notebook interface with using plt.show function. So if you are working outside, you can omit the matplotlib line command. So go further. Here you are seeing the code line. So this line display the original image, and plt.figure is just to create a figure with a specified size. Here we set the 6x6 inches for better visualization. And next line eim.show display the original DICOM images, and also with the matplotlib functions imshow, and the grayscale color map with gray. plt.title is just set the title of the figures to the original DICOM image, and this will show the display the figure with the image and data. So next, here you can see that next we can augmentation. Now we are going for augmentation using OpenCV library. So here are the code. We can see in the line is number 1 for horizontal flip. Similarly, uses the OpenCV function cv2 to perform a horizontal flip on the DICOM images. The argument 1 indices a horizontal flip, and a result of the flip is stored in the augmented image variable. Python and code next you are seeing is about now we can show display the augmented DICOM images. Same code as above for displaying the original image, similar to display the original image. Now we can see that the flipped image here below. So that's all for now. Thanks for watching this. Please subscribe my channel for the same video. In the next video we will do for rescaling the DICOM image. Thank you.